All right, to start up your calibration, the first thing we're gonna have to do is set up your hardware. Today I'm gonna be using the Portrait Display C6 colorimeter and the Portrait Display's G1 as my pattern generator. The colorimeter, I have it right here. It has a counterweight. Let me show you that real fast. That counterweight can be slid along the cord to adjust it, and just needs to be draped behind the TV screen. Hang the meter so that it's centered on the TV. It doesn't have to be right in the center. You do want it pretty close. And make sure that it's sitting flush against the TV. For setting up your pattern generator, the Portrait G1 is a network-based pattern generator. That means it's going to communicate over IP via the network cable. So plug it in. It has a couple of ports on there, a USB-C port, an HDMI port, and a network port that we're going to use. The generator will get power over USB-C. We'll send out a signal over HDMI. And we'll communicate with Calman via the network. You can see as I plug those in that we've now got a signal coming in on the screen. Once the generator has connected to the network, it's going to show an IP address right here. You can see it's syncing right now, and it does now show the IP address. A couple of things to talk about really quickly about this generator specifically, and about what you're seeing on the screen. You'll notice that everything on the screen is dynamic. The point there is that as soon as you plug in the generator, we're going to start warming up the screen, making sure that screen is ready for calibration. Next thing is we do show the IP address. That's how we're going to connect. We make sure that that's nice and prominent. You can see it on the screen right away. Beyond that, we have some version information, so you know if the generator is in the current version or not. If it's not in the current version and it has a new update available, it will show that on this box as well. Once you connect to Calman, the next thing that the generator is going to do is it's going to put up an alignment pattern so that you can make sure that that meter is pretty close to the center of the screen. Again, it doesn't have to be perfectly centered. What's most important is that it is sitting flush against the screen, so there's no ambient light that's going to get in from the sides. Next, we're going to start calibrating this LG TV. The first portion of that is to select which type of TV you're going to be calibrating. I'm going to be calibrating an OLED TV and which mode you're going to calibrate on. Today I'm going to be calibrating this TV for SDR. Okay, and we'll want to connect to all of our hardware. We already have our hardware set up. Our G1 pattern generator is warming up the screen right now. Our C6 meter is right on the center of the screen. We're going to connect to the meter first. Press Find Meter in Calman. It's going to connect over USB. It'll take it a moment, and then we're going to want to make sure that we set up for the picture mode that is most appropriate for the display. So once I'm connected in Calman, you can see that on my hardware tab, I do have a green indicator showing that the meter is connected. And you'll see that there's a drop-down right in Calman window for selecting the appropriate display technology. This is in WRGB OLED. Next, I'm going to find source. The source means my pattern generator. And I'm going to connect to the Portrait Display's G1 pattern generator. And you can see when I did that, it does a search on the network to see if it can see a pattern generator for the G1. It can, so I can just select that. Or if it didn't find it automatically, I can try typing in the IP address manually. If it doesn't detect it though, it's a good indication that maybe we need to check something on the network to make sure that everything is connected to the same network. All right, so I've connected to the generator. Clearly visible that something's changed on the screen. I now have a static alignment pattern. You can see that it does give me this nice alignment window here. I'm going to point out a couple things on this pattern really quick. So I do have these concentric circles. If there's any scaling that's happening on the TV, circles are a good place for your eye to catch it to see if they are oblong or ovalish or if they're actually circles. Next thing is I've got this tri-bar that points right to the center. That way I have a good place so I can identify where center of screen is for my meter placement. The last thing is there is actually a border that goes all around this pattern that's not visible. What that tells me is that in the picture mode I'm in right now, I have some degree of scaling happening that's clipping off the edges. So that's an overscan setting that's obviously clipping off the edge. So that's another element on this pattern that you can't see at the moment. Let's go into the menu and see if we can find that. Okay, you can see now I do have that border. That border is even all the way around, but For the OLED TVs, they're going to have some degree of pixel orbit that's turned on by default that will shift this pattern, this image around a little bit. It's not really visible to the human eye, but it's something that the TV is going to do to protect the OLED screen. All right, once we're connected up, next thing I'm going to do for the calibration is I want to make sure that I have an appropriate window size. OLED TV, I'm going to use a 10% window. We do give some instruction right in the workflow for making sure that we're set up correctly for that. All right, now before I go any further, what I'm going to do is I'm going to take a pre-calibration measurement. That's just to see what the state of the TV is. This is a fresh TV. I've never seen it before, so we'll just see where it is. I don't know what picture mode it's in actually. I didn't look when I had my menu open, so it's perfect starting space for this TV. Let me talk a little bit about what you can see on screen here while these measurements go through. We have a couple of charts on screen. Now I just cycle through what's on those charts. We have a luminance chart. That luminance chart is just going to show us how the display is behaving as it goes from black up to white. That's just going to give us luminance information on there. It's not going to give us any information about the color balance, so how accurate of a white representation there is. Right over from that, we have our RGB balance. That's where we're going to show the color information. So that's where we're going to show what we're seeing right now. On this one is that from the red, green, and blue perspective, we've got more blue in the image, less red and green for a nice D65 white point. You can see on that luminance chart that we are tracking a little high on the luminance overall. Next thing we're going to measure is our color checker. And our color checker, what we'll measure is we're going to measure a selection of different colors across a range of elements that would be visible in real content. So we can certainly measure just the outside of our targets, or we can measure a bunch of points that would fit better within real content. So on the color checker, we do things like a light sky color, a flower color, some skin tone colors, and those are going to give us a good representation of what real content will look like, and we'll measure those across the board. Down below the color checker chart, you can see we have a DE2000 chart for the color checker and a DE2000 chart for the grayscale. What that is it's a measurement of how close or how far off we are from our targets. Let's talk just a little bit about targets. For this calibration, we're going to be targeting Rec 709, and we're going to be targeting a power function 2.2 gamma curve. On Rec 709, what that means is this CIE chart, the diagram, the large wedge shape, is representative of all the colors that the human eye can see. What this highlighted triangle inside is, that triangle represents the color space that we're targeting. So in this case, that color space is Rec 709. That's going to be our SDR standard. And you can see that that does not cover the entire visible spectrum of light. So there are colors that will fall outside of that triangle. What you can see on the measurement data we have is that we have some colors that are oversaturated. Those are the colors that you see here, where, for example, green is outside of that highlighted triangle. And again, on the RGB chart, we see that blue is raised up higher, elevated over the red and green. What we'd like to see on this chart when we're done calibrating is that the blue, red, and green all stack up nicely right on top of each other and are all aligned along this 100 line. We should also see that this luminance, where it does this kind of large bump in the middle, we want to see that so it tracks nice and smoothly along our luminance curve. Let's connect it up to the TV and get calibrating. To connect to the TV, hit Find TV, make sure you select the correct year model, and then we're going to go into the menu on the TV, get the IP address, and do our connection. LG did a recent update on there, and they now show the networking information right at the top of their menu here. Makes it easier, a little bit easier to get to. I have a wired connection, always recommended just for stability of your network. And my meter's just blocking us a little bit here, but the IP address is going to show up right on the screen here. All right, now if this is the first time you've connected to the TV, you are going to have to enter a PIN number. That's a human verification. It's a security measure from LG that makes sure that you're actually there connected to the TV. Enter that PIN number in the Calman dialog box and press OK, and then we'll go ahead and finish the connection. While that's happening, you'll notice that there's going to be a couple of pop-ups on the TV as we go through those steps. And then again, just like before when we were connecting to the pattern generator and to the meter, you'll notice that once we are connected, we have this show a green indicator, and we show the connection information right up in the top right corner of Calman. For the calibration itself, select an appropriate picture mode. Just for the sake of making sure that we are in a good state for starting the calibration, would recommend doing a full DDC reset. Go ahead and press that button, and then we can continue on to the next screen as soon as the reset finishes. You'll know the reset has completed when this tab for the TV stops flashing. It does take a moment. We do need to send a bunch of different commands to the TV to make sure everything's in a good state. But once it's complete, you can hit next. Let's talk for a moment just about the calibration of the LG TV itself. The LG TV does need to be in what it's called Cal Start mode for the calibration to be applied. So we'll automatically check that box for you when you do the reset. But on this screen, we just have you double check and ensure that Cal Start is enabled. Go ahead and press next. Next thing we're going to do is we're going to calibrate this for an appropriate luminance level for our viewing environment. In this case, I'm not exactly sure where this TV is going to end up after I'm done calibrating it. So I'm going to calibrate it a little bit brighter than if it was for a really dim room. That's up to you in terms of what you think you would like for your viewing environment though. If you're in a very light controlled room, you might calibrate it down to 100 nits. In this case, I'm going to calibrate it a little bit brighter, as I said, because I'm not really sure where it's going to end up. And if it's calibrated to 100 nits and it's going to go in a brighter room like a living room or an office space, then it probably will look a little bit dim. This is at 200 nits right here, which is fine for an office viewing environment. So I'm going to leave it right at where it is. Just as a representation here, I'll show you how that control works. Make sure that you know there's kind of 3 ways to interact with this control. So you can drag the control up or down, and to make the adjustments there, you can press the plus or minus buttons at the top or bottom of this control, and those will allow you to make more minor adjustments, or you can manually type in a value based on if you have a specific value that you think is going to be best, or if you want to make a large change pretty quickly. You'll notice also that there is a little bit of a delay when I make a change there and when we actually get the measured value back. We do need to send that control over, and then we do have this blanking. You'll notice that the screen is not staying constant, it's flickering on and off. That's because we do have a little bit of a blanking set up on there to make sure that we aren't keeping that same patch up all of the time on that OLED. So I'm currently measuring 215, 216 nits. We do anticipate that that will go down just a little bit as we go through the next steps in the calibration. As we bring that blue down to calibrate it to red, green, and blue balance, we're going to see the luminance drop just a little bit. Hit next in Calman to move on to the next step. Now this step is where we're going to run our grayscale. So this runs a full 1D calibration on the TV. This calibration is where we're going to get the luminance balanced to our 2.2 curve. So we show that luminance chart there, and it's where we're going to get the red, green, and blue balance. There are a couple of options on there. In most cases, the default options are probably going to be pretty well balanced there. There are some additional options that will do a more detailed calibration. Some of them, for example, we've got a dark detail option that is really geared towards HDR calibrations and is best suited if you have a very sensitive colorimeter. In most cases, that's probably not the best choice for a standard setup. For a home calibration. In most cases, I would say for a home calibration, you can run with the default. I'm going to run the 26-point SDR set, and there are options for how accurate we want Calman to target that calibration. The default in Calman is 0.5. I set mine to 0.1 earlier, and that setting is still in there, so that's why mine defaulted to 0.1, but the default in general for Calman is 0.5 DE. The reason for that default is DE of 1 or less is generally considered to be invisible to the human eye. So if we have DEs of 0.5, that something's a little bit blue high, and then next that's close to something that's maybe a little bit blue low, in theory we should still only have about a DE of 1 across. If you want to take more time and target a DE of 0.1 or target to 0, and Calman will churn away a lot longer, that's certainly up to you. You can do that. There's no harm in that at all. For my case, though, a DE of 0.5 is really going to result in an excellent calibration with no visible artifacts. While it's going through, let me talk a little bit about how Calman's going to do this process. We're going to measure the full grayscale. We're going to start by measuring at 100. Then we're going to skip down to 50. Then we're going to measure 25 and 75%. And the reason that we kind of do that is we're going to measure each point, and we're going to adjust at each point, but we're also going to pre-adjust some of those points first, so that hopefully as we go through, that calibration is going to go more quickly. And as I said, that the reason that we do that is if you think of what we saw on the first screen when we took our pre-calibration measurements, the blue is high kind of across the range. So as we adjust for 100 and as we adjust for 50, we know how much blue we had to take out at 50 and how much at 100, and we can kind of we can interpolate the points in between of what we think are going to be about the right control values. That said, each control point that we're adjusting, we are also going to make that adjustment. So we're going to measure it. We're going to see how close it is. We're going to make some little fine-tuning adjustments. We're going to bump the controls up and down a little bit, see if it gets better or worse, and then move on once we find a good point. So we will still measure each point, but in the process, we're going to hopefully be pretty close while it's happening. All right, and so that 1D lookup table will take a little while to calibrate, especially as we get down to those lower points. What we're going to do is we're going to take a little bit longer samples with the C6. Going to try and get as accurate of readings at those darker levels as possible. Also, we do have that blanking on the screen that I talked about earlier, where we are going to try and protect the screen, make sure that what we're doing is we're calibrating the TV and we're not running into issues of either temporary or long-term burn-in. Now that that 1D lookup table is complete, go ahead and click OK on the dialog box. And you can see, again, talking about what we saw earlier, is that our RGB balance now shows very, very closely aligned balance between the red, green, and the blue. Our DE values are all very, very low. They're almost hard to see on these charts. And then our luminance tracking is tracking right along with our target line. And you can see that here, that our target line was yellow and the gray is the measured values. Those gray values are now just covering right over the top of that target line. Let's move along and calibrate the 3D lookup table. And again, just press the AutoCal button in the workflow. We are going to take a couple of measurements first. We're going to just set our floor and ceiling for white and black levels, and then it's going to give you the dialog for setting up your AutoCal. We're going to go ahead and stick with the default here of the lightning LUT for our 3D lookup table type. What that determines with that lookup table selection is what points we're going to measure when we're going to calculate that full 3D lookup table. Go ahead and select OK on there, and then we're going to start the calibration. Different levels of lookup tables will have different options of lookup tables. We'll have different numbers of points that we're calibrating. So some lookup tables can take a very long time. We have our fixed grid lookup tables that can go up to very, very fine detail if you'd like. Our lightning LUT offers a really good compromise of speed and also accuracy. All right. So it looks like our 3D LUT calibration has completed. What we're going to do next is we're going to just go ahead and do a quick set of readings, just validate how the calibration looks, and then we'll move along. All right, go ahead and press next. What we're going to look at next is we're going to look at our brightness and contrast patterns. The idea with the brightness and contrast patterns, we do want to be able to make sure that the images the content that is below black is not showing up, and that we are able to see things coming out of black. On this screen right now, I am obviously have a decent amount of surround light in here, but I don't see any of my levels coming out of black right now, so we can go ahead and adjust our black level a little bit. And again, this control works the same way as the one I used before, where you can either slide it or you can use the incrementers to just press up and down, do one single increment up and down, or you can type in a number. I'm just going to type in a fairly large number, make a big change, just see where we're good. Okay, so as I move that control up from its default of 50 up to 75, you can see that now you can see more clearly all these levels that are on the screen. Our video level black is 16 in an 8-bit realm, so you can see 16 here is denoted with a red instead of all the other numbers. We use a light gray. And so you can see that what we're seeing on here is that we do have values that are below 16 that you can still see. So ideally what we want to do is we want to set that to just the point where our 16 blends in with a black background. We do start seeing these boxes, these patches for 17, 18 and above. So those are our first levels where we're coming out of black. So I'm going to just adjust this black level control back down. I assume that should land someplace fairly close to where we started. Looks like that's maybe just a little bit too low. Turn it up a couple of clicks and just see where we are. Okay, I don't know how well this will come across on camera. Obviously, this is going to be something that's hard to see, and you want to give it a close look. I can see that boxes down to about 19 right now. I'm just going to go up a couple more clicks. Okay, and so I can just barely make out the box at 17 if I look really close. That part probably won't come across well on camera, but that's okay. So when you're looking at this brightness pattern, just know that what you're looking for is that our black is going to blend into our black background and that the values come out. We're just going to start seeing those. Our contrast pattern functions fairly similarly in that we're looking at a video range signal, so 235 is our white level, but we treat it a little bit differently. There is valid content above video white, and we call that our super whites or above white. And so it's fine that we're seeing all these boxes up above 235. We just want to make sure that we do see at least up to 235. There are certain displays where you can turn contrast up too high and you can clip down below, and that means that you'll start losing content below 235. That's obviously not an issue here. The other thing that we're going to look for on this test pattern is we're going to look for any signs of color shift. So if we have contrast turned too high, and again, doesn't appear to be an issue on this TV, but on some TVs you can find that if you have contrast turned up too high, what will happen is one of the color channels doesn't keep up. So maybe blue and green are still there, but the red channel just doesn't keep up as well. And so what we'll see then is we'll see some color shift. We can also measure for that, and let me show you how we measure for that. We have a clipping with peak white test that we're going to run. I'm going to press the read series here. And so what we're going to do is we're going to measure just the points of the grayscale that are right around the top. So we're going to measure just up to 100 and then up above 100 up to peak white. Peak white 109% or 255. And what we're going to look for is if we see that flatten out on this chart. So here on the luminance chart, what I'm talking about is right here at about 107%, 108%, we do see that our luminance flattens off. So that means that's our clip point. If I turn this up, my contrast control up further, we'll just remeasure and see what that looks like if that pulls that clip point down further or not. Okay, so on this luminance chart, you can see that now when I turn that contrast control all the way up to 100, that we're now clipping off pretty much right over just past 100%, about 102%. And I'm going to show you what that looks like on that contrast pattern again. So on this contrast pattern, we now don't see any details at all on our pattern. So obviously we don't want that to be the case. So I'm going to go ahead and turn that contrast control back down. I'm going to just set it back to 90 where we defaulted it to before. And you can see we now have our content showing up there again. In terms of peak luminance, we did measure that earlier. This peak luminance is going to measure all the way up to 109%. So it's measuring the peak luminance at 255. So we'll go ahead and look at that again on our next, when we just do our final calibration. But it's measuring peak luminance for 255 right now at about 230 nits. That's well within the range of where I was kind of looking for this TV. So that seems like a good value. If we did want to make changes to that, we can certainly adjust this control for the OLED light as well. And I'm just going to measure clipping. So if I just measure clipping test, what that's going to do is we're not going to measure that super white anymore. It's just going to measure up to 100%. And that's going to give us our peak luminance for our legal range. Now I did turn that OLED light down quite a bit, so we'll see what our peak luminance is with that turned down. So now I'm down to about 100 nits for my peak luminance. Again, that would be great if I was in a really light controlled room, but I think this TV is going to stay in an office setting where it's going to be a little bit brighter, so I'm going to turn that back up. And you can take those measurements by measuring the full series. Another way to do that measurement is you can just do continuous readings. That way it's just going to keep cycling through reading after reading. We will still do that screen blanking that I've talked about earlier, but it'll allow you to see what those changes are more quickly and get to the value you want to see. I'm going to leave it there at about 215. And you'll notice that the rest of my values here look a little bit strange on that luminance chart, and that's because I've made some adjustments to that top point, and all of the other values are going to be calculated based on the white value. So that top point changes, that's going to change how the rest of the values look on that chart. Once we are done with that step, we're actually pretty much done with the calibration. To finalize, we're going to go ahead and uncheck the Enable Calibration button, take that TV out of calibration mode, and we're going to run a post-calibration verification. The reason that we do this as a full separate step is once we've made all of our adjustments, what we want to do is make sure that we run a full sweep of the TV we're going to do the same sweep that we did at the beginning. We're going to measure the full grayscale. We're going to measure that color checker. And the reason we do it separately is that we want to make sure that if there was any interaction between the controls, that we're seeing that as we measure through the whole, as we do that full assessment afterwards. So for the red, green, and blue balance, we notice that those are really tightly balanced. That's exactly what we wanted to see from that grayscale calibration. You also notice that I do have this little bit of a bump here right at the bottom end. That's from me turning up that OLED light so I can make sure I got all the details of those bottom points. You'll also notice that for luminance tracking, on the luminance chart here, we're tracking that with these gray points. The gray line is lining up right along that luminance curve that we're targeting. As we go into the color checker, you'll notice that with each measurement that we're taking, the circles are the measured data, the boxes represent our targets, that the circles are lining up very closely in the target boxes. Obviously, we didn't measure a lot of these points are points that we didn't calibrate at specifically. So what that means is we're measuring at different points than we calibrated, so we're seeing what the calibration overall looks like, even for points that we didn't necessarily touch while we were calibrating, which is nice because that way we can make sure that the calibration applies for all of the picture content that we're going to see. As such, we'll expect some of those to not be necessarily a perfect DE of 0.5 or lower, but we expect them to all look still pretty good. So as these go through, what we're going to show on screen is we're going to show a max error and an average error for each type of run that we're doing. So for our grayscale, for example, that's completed already, we did have a max error of 1.4. If you were a trained colorist, you might notice that. In most cases, that would not be something that would really be very visible to the human eye. And our average error is 0.6 for the grayscale. And our color checker, it's not quite complete. We've got a max error of 1.5 right now and an average of a little bit under 1, so 0.8. So those look like they're great values. We have a nice looking calibration there. I'm going to go ahead and just go to the last screen here. So we do a pre and post calibration comparison. And on there, we're just going to show you here's what the TV looked like when you started out, and here's what it looked like after it's done. So we're going to show you again that the RGB balance charts for our grayscale. We're going to show you the DE values, and then we're going to show you those color checker charts. In this case, our RGB balance chart shows a max DE of 30 for our grayscale and an average of about 20. And afterwards, we had a max of 1.4 and 0.6. Again, the lower the number, the more accurate we are to our targets. And similarly, on our color checker, a drastic improvement, and pretty much all of those are now lining up on the boxes just as we'd expect. So at this point, you're done. You can save the session so you can review it later. You can start a new calibration if you want to do an HDR calibration or a Dolby Vision calibration on your TV, for example. Or if there's something that still looks a little bit off, if you want to make some adjustments, you can hit back and you can go back to any steps that you wanted to look at. All right, so we've already calibrated SDR on this LG TV. I'm going to go through and do an HDR calibration next. On Calman, just go ahead and select New Cal. And that's just going to skip us right back to the beginning of the workflow. We'll be able to skip a few of the steps we did earlier because we're already done. We are still going to tell Calman which type of TV we're going to be calibrating. In this case, we're going to select OLED and we're going to select HDR. Go ahead and hit next. I don't need to set up any of my hardware this time, but I do need to change one important thing, which is I need to feed this TV an HDR signal. To do that, we're going to go into the settings for the pattern generator. And right here, we have an HDR flag in there. We're going to just set that to HDR 10. And you'll notice that we now show an HDR bug right up here in the top window. And it's going to give us a notification the first time we go into HDR on any of our HDMI inputs. Just go ahead and click OK for that. And we'll move on. For pre-calibration readings, again, purpose here is we're just going to see what the TV looks like when we're starting. And then we'll be able to compare that after the calibration is complete. Now again, if this is a fresh TV and it might not be in a calibrated mode, we'll expect it to be probably pretty blue. We expect our luminance tracking probably won't come super close. Once you've selected a more calibrated mode, or if you're going in to recalibrate, we'd obviously anticipate that to be a lot closer. And so as we're just wrapping up those color checker readings, next thing we'll do is we'll go through and get going on the calibration. Obviously, we're already connected to the TV because we just came from doing another calibration on the SDR picture mode, but we do want to select an appropriate picture mode for HDR calibration. I'm going to go ahead and select HDR Cinema. And now there's a couple of things that we're going to do right away after we select that picture mode. We're going to make sure that the settings are correct for HDR. There's going to be an HDR flag that we need to set, and make sure that the color space is set to BT 2020. Those are both done when you select that picture mode for HDR Cinema. So you can just confirm that those are set on the screen appropriately. And then again, just to make sure we're in a good state for calibration, I do recommend you hit that full DDC reset. As soon as that reset's done, we're going to go through and we're going to do essentially the same steps that we did for our SDR calibration, where we're going to do a 1D lookup table calibration, and then we're going to do a 3D light. Similarly to with SDR, we want to make sure that we are in a cal start state. That's extra important on the HDR mode, because the cal start, what it makes sure that we do is we're going to calibrate to the panel native behavior, which is to follow a gamma curve. So we're not targeting that PQ curve with a hard clip. And instead, we're going to calibrate it to the panel's native behavior, which is tracking along with a power 2.2 function. And then when we re-enable the PQ processing on the TV by going out of cal start, that's when we're going to validate against the PQ again. Press the AutoCal button to start the 1D lookup table AutoCal. We are going to take a couple measurements first to just set our baseline, and then we'll give you some options for the AutoCal, what points you're going to calibrate. There's some default levels that are in there. I'd recommend for HDR that we just select the LG 20 points HDR. There are some additional levels that will have more fine detail, especially if you're coming out of black, that are really valuable if you have a very, very sensitive professional grade colorimeter that can read very dark levels accurately. But in most cases, the 20-point HDR is probably going to be a really good selection. Setting the DE target, our default in Calman is 0.5. I turned mine to 0.1, and that setting is still on my preferences right now, so I'm going to adjust that to 0.5 before I start this. All right, so once your 1D lookup table is fully calibrated, you'll notice that, again, what we're looking for there is that our red, green, and blue balance are tracking very close together and right along the line at 100 here. We're looking for DE values that are very low, and we're looking for a luminance chart that is showing us tracking right along with that 2.2. And again, that's because the PQ processing is turned off when we're in calibration mode on the TV. We're going to turn those on after we complete the calibration, before we do our post-calibration. For doing the calibration on the 3D lookup table in HDR specifically, what we're going to do is we're going to calibrate a matrix LUT. So press the AutoCal button. Again, we're going to take those first measurements to set our baseline, and then we'll get our dialog box for doing the AutoCal. Go ahead and select Matrix LUT for our HDR AutoCal. And it should be pre-selected for you already. And then you can just hit OK. The Matrix LUT is going to go pretty quickly. We're going to just measure our primaries, black and white. So the set of measurements is going to be very fast for doing this Matrix LUT, and we're going to be complete pretty quick. All right, so that LUT is complete. To finish up the calibration for HDR mode, one thing we do need to do is we need to set what the peak luminance is and report that back to the TV so it knows how to appropriately apply the PQ. To do that, we're going to measure our peak luminance on the display. Looks like I'm currently measuring 722 nits, and we're going to just change that value on our luminance control there to reflect that it's 720. We're going to hit our tone map upload, and once that's done, we can go ahead and hit next. And again, we do need to make sure we go out of our cal start mode before we do our final post-calibration measurements, so that we are measuring with the PQ processing applied again. Just uncheck the enable calibration button, hit next in Calman, and we can do our read series to measure our post-calibration behavior. While we are measuring that post-calibration response, let's just review what we're seeing on the screen. Our luminance chart is going to show us the luminance behavior that we anticipate. So this is our PQ targets. The goldenrod yellow line here represents our target luminance, and the gray line is going to start populating with these measured values pretty soon. And what we anticipate to see on this chart is we anticipate to see that the gray measurement line is just going to essentially cover up that goldenrod colored target line. The DE chart gives us our measurement of how close or far off we are from our targets. In this case, what we would hope to see is that our DE values are as close to 0 as possible, ideally under 1. The red, green, and blue RGB balance chart just tells us how accurate our white point is for our D65 target. What we anticipate seeing after calibration there is that the red, green, and blue bars all match up together and are all centered right along the 100 line. For our color checker, do note that we probably will see a little bit higher errors in our HDR color checker than we would on SDR, for example. But what we'll expect to see is that all of the values, the measured values, are going to come very close to the target squares, and that we should have DEs close to or under 1 in almost all those values. All right, so those grayscale measurements are completing, and you'll notice that the tracking along our luminance targets here is very, very good, that our red, green, and blue balance are all balanced right along that 100 line. Our DE values here are all very good. We do have a max error of about 1.4, and that error comes into play right here where we're going for our clip point on PQ, which is kind of the point where we'd most anticipate seeing that. We're starting the color checker readings. Our color checker readings, again, what we expect to see is the squares represent our targets, and the circles, as they populate there, represent the measured data. We anticipate seeing that those are all going to line up pretty closely. In HDR mode, we do that matrix select calibration. We do anticipate that there might be just a little bit more error there than we saw in our SDR modes, but we should still see a very good calibration at the end. All right, and as we wrap up the last of those color checker readings, you can see that for our grayscale and for color checker, our average DE is still under 1, which is exactly what we'd hope to see there. Our max DE in both cases was just a little bit over, but not very much. We got a max DE of 1.4 for our grayscale and a max DE of 1.4 for our color checker as well. So very good calibration overall. Let's look at that post-calibration screen. Post-calibration comparison screen, again, just gives us a chance to see what it was before we started and what it was after we started. In a lot of cases, if you're doing a calibration for a second time, we'd anticipate to see very small differences there. But in this case, we started from a kind of out-of-the-box picture mode. I don't know what picture mode it started on, actually, and went through a full calibration with final results that are looking really good. Again, we've got that RGB balance chart showing there, the DE chart, and the color checker showing all that information we just talked about in the previous screen. At this point, you can save the calibration session to review it again later. You can start a new calibration if you want to do another picture mode, SDR or Dolby Vision. And if there is anything on this that is giving you pause that you want to look at again, you can certainly skip back through the workflow and go and redo any parts that you want to redo. If you do need to restart parts of the calibration, don't forget to enable Cal on the TV. While I'm still connected to this LG TV, I just completed an HDR calibration. Next, I'm going to go through and do a Dolby Vision calibration. In Calman, you can go ahead and select New Cal. That's going to take us back to the beginning of the workflow, and we can get set up for our Dolby Vision calibration. Now, again, we won't need to reconnect to our hardware since we're already connected, but we do need to make sure that we are setting up our signal generator for Dolby Vision correctly. On the G1 generator, make sure to select Dolby Vision. Now, there are a couple of different formats for Dolby Vision. We're going to connect by going into what's called perceptual mode. Then we're going to do our pre and post calibration with Dolby Vision Absolute. And when we're doing the calibration itself, we're going to go into a relative mode. That allows us to calibrate to the panel's native behavior. Now, for Dolby Vision, we are going to use 10% Windows again. And you'll notice that we do show Dolby Vision notification flag up there on the top right corner when we go into Dolby Vision. We are going to check and make sure that the Dolby Vision mode is set up correctly. So to do that, we're just going to pull this up. If it's showing up as a white square, that's great. We are in the correct Dolby Vision format. If for some reason it's not showing up as a white square, then that indicates that that Dolby Vision is not set up correctly. An incorrect mode would normally look like a red background with a green square in the middle. And just as before, I'm going to run through a series of pre-calibration measurements. All right, just like with our HDR mode that we did before, we do need to select an appropriate picture mode for running our Dolby Vision calibration in. I'm going to go ahead and select Dolby Vision Cinema. You'll notice that as we do that, we're going to send some signals to the TV to change the picture mode, so that you will see some pop-ups as that happens. Next, we are going to make sure that HDR and BT 2020 checkbox settings are set there correctly. They should be set already for you. And we're going to run the full DDC reset before we continue on with the calibration. Running that full DDC reset just makes sure that we are in a good state to start the calibration. And just like before, as that reset happens, you'll notice that there is pulsing on the display tab in the top right. As soon as that's done, we'll know that the full reset has finished. All right. Now, this is a really important step that's easy to miss, but for Dolby Vision specifically, we need to change our Dolby Vision picture, or our Dolby Vision signal type, from absolute to relative. So in addition to making sure that the enable calibration checkbox is checked there, and so we'll be in a 2:2 matching the panel defaults for our calibration, we also need to make sure that the signal is set up correctly. Go into your source tab, and Dolby Vision mode, make sure you change that to relative for the calibration. And we're going to press AutoCal. And for Dolby Vision, we're going to use the default HDR points for the Dolby Vision calibration. And with the AutoCal dialog box up, we do have a default set of 20 points of HDR that we're going to use for Dolby Vision calibration. And just like when we did the HDR calibration, there are a bunch of other options in there. You're welcome to select them. Some of those options will have more points at lower luminance levels, for example. It will extend the time of the calibration, and they're really going to be best suited for a more professional meter that is really high sensitivity to low light levels. In most cases, I'd say for calibration for home TV, we're using really quality meter that is not geared specifically to read super low light levels. The default sets of points are probably going to be the best option. All right, and once that 1D lookup table is all calibrated, go ahead and close out that dialog box letting you know, and we can skip forward to the next screen. Now for Dolby Vision, we aren't going to calibrate a 3D LUT. Instead, what we're going to do is we're going to create a Dolby Vision configuration file, and we'll upload that to the TV. And so that's going to do a lot of that color correction management. So to create the Dolby Vision configuration file, just press the button on the screen. It is going to prompt you to select a location to save a copy of that file. I'm just going to select my desktop. Now the Dolby Vision configuration file will actually get written automatically, or you can load it manually. We have the instructions for loading it manually right here in the workflow. All right, once that has been created, click OK. And as I said, you can load it manually. Just press the Dolby Vision upload, and it will bring up a dialog box, and just choose the Dolby Vision user display configuration. Once that's done, go ahead and hit next. And now, just like when we were going into the calibration, we do need to make sure that after the calibration, we switch our metadata for the Dolby Vision and disable the cal start. Those are two things that are going to allow us to measure the display in Dolby Vision as it would actually be watched. You can press the change Dolby Vision metadata, or you can just go through and open the source tab and change the Dolby Vision mode from relative to absolute. Disable cal start. And then we're going to hit next, and we're going to do our post-calibration measurement. All right, and it looks like our post-calibration measurements are complete. We've got excellent results there on both the grayscale and the color checker charts, showing max error of 1.5 and 1.8 respectively, and then average 0.7 and 0.6. So those look really good. We'll go ahead and take a peek at our post-calibration screen. In our post-calibration screen, we do see a lot of improvement there in terms of the luminance behavior tracking particularly, and then that tracks well with the color checker being a little bit tighter as well. So post-calibration results are looking excellent. All right, we hope you found this tutorial helpful. If you do have any questions, please do reach out to our support if you have any, or sales, depending on what you need. And by all means, do let us know if there's videos or content that you're specifically looking for that would be helpful. Thanks again.